So what your end result is going to be is a double-stranded double-stranded DNA molecule, and this cDNA just means that it was made by reverse transcriptase. And so now that we have this double-stranded DNA molecule that contains the codes to build this polypeptide of interest, we can now take that and we can inject that into a plasmid. So reverse transcriptase, again, I just want to drive a point home that it degrades messenger RNA and it builds new DNA. It's a DNA polymerase that builds new DNA, it degrades the messenger RNA, and then adds in new DNA. And so now what we have, though, is we have a group of double-stranded DNA molecule that codes for the gene of interest, or that codes for the polypeptide of interest. It is the gene of interest. And what happens is it has two restriction sites on it. And what we can do is we can expose this cDNA, which is DNA made by reverse transcriptase, and the plasmids to the same restriction endonuclease. And what this is going to do, so you say you have this here, and here's your plasmid. Well, restriction endonucleases, as we talked about earlier, it cuts at a specific nucleotide sequence, and it cuts at a sequence that is palindromic. And what it's going to do is, restriction endonuclease is going to cut at the same points. So if it cuts at a same point on this, it's going to cut at the same point on this. If it cuts at the same point on this DNA, it's going to cut at the same points on the plasmid. And what this is it opens up the plasmid, enables us, draw like that. Opens up the plasmids, and enables us to insert foreign DNA, or in this case, the DNA that we had made from reverse transcriptase that contains the peptide of interest. And then what we do is we add ligase to staple everything together, and what the end result is, and I don't know how clearly it is to see this, but here's your plasmid. This purple thing here is the gene of interest on the plasmid. It is a non-intronic eukaryotic gene of interest existing on a plasmid. And what's something else that we know about plasmids? Well, they contain ORI, so replisomes can come in, they can replicate it, replicate it, replicate it, replicate it. This plasmid then can go on to be, we can insert that into another bacterium, and this bacterium will have that plasmid, and that's how we can transform bacteria with recombinant cloning vectors to produce things like insulin and produce things like human growth hormone. Because before that, we got it from pigs and cows, and whenever we took the insulin from pigs and cows and injected it into humans, what happened was anaphylaxis, and this would, very risky type stuff. And so when we can do this, we can mass produce human proteins. And this is how we can make insulin, and that's how we can make human growth hormones for people who are midgets or dwarfism or little people, whatever the word is, I don't even care. And we can produce fully developed, and we can grow proteins that are made within the human body. So I hope that's helpful.